So please open the model we were working on in previous session. So that was model 5.2, right? I believe. So that was model 5.2. Please open the model. And if you remember in previous models, so let me just go over the model really quickly. So what we were trying to model is a call center. So we had a call center in which the calls come in. We have a record module that records the attempted calls when they come to the system. However, in this call center, we have only 26 trunk lines. When all these 26 lines are busy, the customers that come to the system get rejected. And then so here we have a decision module that just checks if we have any line, any trunk line available. If no, if you don't have any trunk line available, the customers get rejected, and we count how many customers got rejected. In the very first version of the model, we just counted total number of customers that were rejected. But in the version of the model that we work on in previous session, we actually created a set of the rejected calls. And in this set, we defined one counter for each hour during the simulation time. We run the simulation for 10 hours, so, or basically this call center is working for 10 hours. In this 10 hours, we define one counter for each hour, and then we wrote the rules here such that the rejected calls are counted in the hour in which they get rejected. Okay, so at the end, we have 10 different counters, and each counter counts number of calls that were rejected in that hour. And the reason we did that is because we wanted to look at the number of rejected calls at the end of the simulation and see if there are specific calls in which, specific hours in which we have a lot of rejections, then we may need to hire more staff in those days. So that's why we decided to collect them in this way. But can someone tell me what is a set? That's one of the concepts we learned in previous section. Can someone tell me what is a set?
It is a collection of resources.
It's a collection of objects, right? So it's a collection of similar objects. Here, for example, this set that we define and we call it rejected calls is a collection of counters. Here, basically, you can specify the type of objects that this set is going to be a collection of. For example, this here, I have a bunch of counters. So this set is a collection of counters. But we also define some set of resources in which we put some similar resources that are doing the same thing into one set. And then when we wanted to define the processes, we said this process is using a resource from this specific set. That's what we did. So we can define sets from different objects, sets from different entities, sets from different tallies, and so forth. So the two that we used in previous session was sets of different counters, sets of different resources, okay? So a set is a collection of similar objects, and these objects can be counters, resources, entity types, and so forth. And then if there is enough line or there is an empty line, then we seize the line, and then we decide on the type of the call. Is it a technical call? Is it a sales call? Or is it an order status call? If it's a technical call, then we also have 3 types of products that this call can be related to. It can be related to product type 1, product type 2, product type 3, with a chance of, I believe, 35, with a chance of 76. They can be, no, here. With a chance of 25, they can, oops. Yeah. With a chance of 25%, they can be a call related to product type 1. With a chance of 34, they can be a product type 2. And with the other chance, they can be a product type 3 type of questions. And here, what we did is that in previous session, we developed an assign module in which we not only gave different entity types to different type of technical support calls, we also give them different pictures so that we see them differently during the animation. And then we also created an attribute, we call it tech call type. And in this attribute, we assign value of 1 if this call is related to product type, product 1. We assign value of 2 to this attribute if it's related to product type, product 2. And we assign value of 3 to this attribute if it's related to product 3. Okay, so we define this new attribute and we assign the values in previous session as well. And then at the end, we had the section, we said that of these technical cards, 4% of them can't be resolved by the technician. So we have to say goodbye to the person and we have to ask or send their questions to some out of office research center. They do the research, they get back to us, and then we have to call the person again and tell the person that, okay, this is the answer that we found for your call. One thing that we also learned, but before I continue with this section, as we try to answer any one of the technical calls, one thing that we learned was that the resource that we use for the set for any one of these operations came from a set. Previously, our resources were just resources, but here we learned that we can put our resources in different sets. And the reason is that if we just define a resource and we say, oh, we have 6 of these resources, we don't have the option to say that, oh, for example, this resource can be used in doing several tasks. Okay, so that's why in the previous model, we basically define a separate resource for all the people who were in charge of technical support, and then we put different resources in different sets. So let me go back to that again. So here we define basically 3 sets of resources. We put all the people that were in charge of different product types into their own set. And if you remember, the order of these resources in the set was also important. The first ones were the ones that were in charge of only this specific product type 1. The last 2 ones, for example, Anna and Sami, were the ones that could not only work on product 1, but also product 2 and product 3 as well. So that's why we listed them at the end, so that when a call comes for product type 1, we use the resources that are only for product type 1 first, and then use the resources that can also provide service to other calls, because if they stay idle and a call for other calls come in and those staff are full, then we can use some of this staff. So we wanted to put them in the set in the order that the initial resources are only in charge of a specific product, and the resources at the end are the ones that are in charge of multiple products. And also, if you remember here, when we assign this set to be the resource, to basically the operation to use this set for the resource, here we also use the selection. Preferred order basically meant use the resources in the order I have put in the set. So that order matters. So that's why we put preferred order. And here in this specific attribute, we kept the index of the resource that has been used. And what do we mean by the index of the resource? If I go to a set again, and if I click on this set of resources, basically this, when I define a set, it's like I put these resources in a vector, okay? So the first one has index 1, index 2, index 3, index 4, index 5, okay? So if I assign Molly to that operation to answer that call, then the index of Molly is 3. So we want to save that index in that attribute. And the reason that we wanted to save that index in that attribute is that when the call comes back from outside, we want Molly, the same technical person, Molly, to be the person who is going to call the customer back and is going to provide the answer to the customer. So that's why we wanted to keep track of the index of the agent who answered the customer. So we created an attribute, a tag on each customer. In this tag, we put the index of the agent who served that customer originally. And then when the call comes in, then we first sees the agent, First, we are going to seize the agent, then Molly, and the same person that answered the call initially, and then we are going to seize a trunk line because now we have to get a hold of the line as well. Then we answer, we release the resources, and then we are done. Okay, so in previous session, we learned that how to keep track of the index of the resource that provides service to a customer, and then later how to basically, again, find that person. If you remember here, when we said that, okay, we are going to call back the customer for the resource we are going to use a set, which person in the set, we said, okay, this time, instead of a preferred order, we are going to pick a specific member. And who is that specific member? That's the person whose index is in this attribute that the customer carries with himself or herself, in this tag that the customer carries. And that way we could get a hold of the same agent that answered the customer initially. Okay, so we learned to do that as well. So a couple of things that I want to mention here. First of all, here, if you remember, first I seized the same agent, and when the agent is available, I seized a line to be able to answer the customer. So you may ask why I don't seize the agent and line in the same operation, right, in the same process. So here is a process, right? Why not I just seize the same agent here as well, because I need two resources. Why not I just do both of them here to say, oh, this call needs a trunk line, and also I need the same an agent, and this agent is Molly, blah, blah, and I can do the same here. So why I don't do all of them here? Why I seize Molly first and then the call? The reason is that if I put both of them here, in Arena, then both of these should be available for this process to work. If, for example, just Molly is available and trunk line is not available, this operation would not be performed. Then Molly gets busy doing something else. If one line is available but Molly is not available, again, this process will not be performed. So if Molly is available but one trunk line is not available, again, nothing would happen, and vice versa. So both these resources should be available for the operation to work. So because of that, I try to put them separately so that if Molly is available, at least let me get a hold of Molly and just keep it here, and then check for the line. And if the line is available, okay, get a hold of that, but at least Molly is available here as well. So that way, there is a better chance for me to be able to get a hold of these resources that I need, as opposed to putting both of them in the same processes. Okay, so this structure would give me a better chance of getting a hold of the agent. Even if there is no line, that's fine. The agent is available, let me get a hold of the agent, and then I wait till the line is available, and then get a hold of the line and call the customers back. Okay, so that's why we put these resources in two different seize operations, because that gives us a better chance to get a hold of the resources that we need. And one more thing that I want you guys to pay attention to is that, if you remember, we said here, we said when we get a call, we get a return call, so we need to call the customer back. So I'm going to use the same resources, right? So still, I'm going to use the same set, the product type 1 set, and I'm going to use the same person and so forth. However, I gave higher priority to these calls. So we said the calls that are returned, they have higher priority. So how did I specify the higher priority for these customers here in the priority? I picked high. Always the default is medium, right? So I picked high. So basically, this seize operation and this seize operation that I have here in the seize delay release, both of them are going to get a hold of people in set 1 for the product type 1 set. These are the resources that are in charge of calls for product 1, right? However, and these seizes have different lines. So this one has its own queue, this one has its own queue. So they are going for the same resource, but in different queue. So how can I make sure that these customers are the ones that have higher priority? So here in the priority, I change the priority to high. Okay, so that's basically the second method that you guys learn for setting the priorities. So these are two different seize operations, two different queues. However, they are going to seize the same resource. Product type 1 set the same resource. If you want one of these queues or some of these entities have higher priority than others, then here you can specify the priority of those type of customers or that specific queue. You can specify the priority in seizing that entity. Keep that in mind because you would need these features over and over in future. Okay, so we basically did that for type 2 products and type 3 products as well. So similarly, this seize operation and this seize operation, both of them are going to use product type 3 set, the same set of resources. However, there are two different queues. They are going to go for the same people, the same resources. The only way I can tell the simulation that these people in this queue have higher priority is that here in the priority I put high. And I said this is the second method that you guys learned because the first method, if you remember, was the one we learned I think 2 weeks ago when we seized the queue, but we used the same queue. You remember we seized a queue, we seized a resource, but we used the same queue, and then later we went to the queue, if you remember. We went to the queue, for example, I don't know, any one of them. And then here for the queue, we specified the priority. We said, oh, the priority is based on the attributes. The one with the lowest attributes has higher priority, or the one with the highest attribute has higher priority. And one thing that you have to remember is that if you're going to use the same queue and use attributes to specify priorities, you for sure have to check the shared, which basically means that these different entities that have different attributes are sharing the same queue. Okay, so that's what we learned already in, I think 2 weeks ago in one of the models that we did. So that was the first method for capturing priorities of entities to get processed on a specific operation. What we did in previous week was the second method for capturing priority, which I think is an easier way just to make sure that you specify the priorities here. Let me see, there was a question in the chat. What is the function of tech call type? Oh, okay, I'll talk about it today. So the question is saying that here we assign an attribute in previous session, right? Tech call type, and we gave it 1, 2, 3. So the question was that, why did we assign this attribute? This is something we didn't get to finish in previous session, but I'm going to talk about it today. Okay, any questions? So that was a review of what we did in previous session and what I wanted to talk about. Any questions so far? Okay. And if you remember when we ran the model, we got this error that basically said the rejected calls index is beyond its range. So let's see what does that error say. Okay, so let's go to the rejected calls. Remember the start of the model when we calculated the rejected calls for each hour? Okay, so here we basically said that use these specific counters. So these are the rejected calls. So this is the set that we define, right? And we told the simulation how to calculate the index of the set. So look at the time of the simulation divided by 60 plus 1. Look at the integer value, and that is specified the index of the set. So in this set, the rejected call set that we already defined and has 10 members, period 1, period 2, all the way to period 10. Here we tell the simulation how to find out this call has been rejected in which period 1, 2, 3, or 10, because we run the simulation for, or the call center works for 10 hours. And then we specify the index here. However, when we run the simulation, you see that we even got to the hour 700, and still the calls come to the system, and still this and the calls are getting rejected because the lines are not available, and so forth. So why does that happen? Click on the first create module and click on the schedule. If you remember, we defined an arrival schedule. So we had a terminating system, right? And for this terminating system, 2 sessions ago, we learned how to define a dummy entity and how to use the assign module to change some of the variables related to this this arrival module, right? This create module, so that we can stop the simulation from creating any entities after minute 600, and so that it's a terminating system, because we don't want any entity come to the system after 600 minutes, and we want the simulation to still continue working till everyone is out. So in previous session, we said, okay, we are going to get rid of all those. So that was the first method for us for capturing this whole concept of terminating system, how to stop the simulation from creating any new entity after a specific hour, and how to still let the simulation to run till every entity in the system is out. Okay, so that's what we learned in 2 sessions ago, was the first method for capturing the terminating nature of this system. Okay, what we learned in previous session was the second method for still capturing the terminating nature of this system. And in this one, we created a schedule. We created an arrival schedule, and in this arrival schedule, we created that because the arrival rate was different. It was not that during the whole 10 hours of simulation, 20 customer arrives per hour. Basically, in each half an hour, the arrival rate changed. That's why we defined this schedule, and we said the unit of time is half an hour, and each unit of time means in each half an hour, we get customers with different rates. However, what happens in the simulation is that at the very last half an hour in the system, when the customers come to the system with 30 customers per hour, the simulation, if the simulation continues running, the simulation will use this rate, basically. If the simulation continues running above 10 hours, still the customers will come to the system with what rate? With this rate, okay? So that's why we get that error, because even after 10 hours, still customers come to the system, and that's why, and still the customers get rejected, and we wanna put them in this rejected calls per hour, and now we have more than 10 count. We need more than 10 counters to count number of customers per hour that got rejected, and since we don't have more than 10 counters, we get the error. So how then I can tell the simulation to, let me go back to the schedule, how I can tell the simulation that I don't want any new customer to come to the system after the 10 hours of the working time of this call center is out. How? I'm going to create a new row, and in this row, I say the arrival rate is 0, and let's say for how long? Let's say for 2 time step, and time step here, or time unit, is half hour. So basically I say, okay, for an hour, no customer one is going to come to the system. So the arrival rate is 0. For how long? 1 half an hour or 2 half an hour, it doesn't matter. So I define that 0. So what happens then is that not only no entity comes to the system after the 10 hours of simulation is over, of the working hour is over, but also if the simulation needs even to run longer hours, 3 more hours after the 10 hour is over, for all of them, the arrival rate to the system is 0 because that's the last one. So if I need to continue system for any hour beyond these 10 hours that I defined on the top, so this is my first 10 hour that I define on the top, right? If I still not to need to run the simulation beyond these 10 hours, for the rest of that, since the last one that I defined is 0, for anything after that, the arrival rate to the system will be 0. So we don't get any new arrival time, any new arrival to the system. Okay, so let's press OK and run again. Okay, so it says simulation ran to the completion. So we didn't get that error that we did originally. Okay, so here we can see a bunch of our results. So for the entities, we can see the time. So for the order status calls, for the sales calls, for the tech product type 1, 2, 3. Sorry guys for the background noise. So we get all of this, and remember, one of the things we defined in the assign modules were different entity types, and that's why although I initially had one entity and it was incoming calls, when I created the attribute, when I created entity type in those assign modules, now the simulation created the results for each one of these entity types. Okay. So we can see all of the results. What I want you guys to pay attention to is the user specified results. So if I go to the counter, so here you see I have period 1, 2, 3, 4. So here I can see, for example, I have had more rejected calls in period 5, 6, 7. Okay. So that gives me a sense, for example, of when these calls were rejected the most and so forth, if I want to add some additional customers later on. Did we define this together? Yeah, so I'll need to tell you about that. Okay, so you guys only had the count, right? The counter. And this period 1 to period 10 basically is the one that is telling you how many customers were rejected in each period. Attempted calls tells you how many calls came to the system, and completed calls tell you how many calls finally left the system. And obviously the ones who didn't leave the system were the ones who were rejected because the number of the lines in the system were full. Let's go back to the model. Any questions so far? Okay, there is a question. Okay, Yiding has the same. Just give me 1 second, Yiding. I'll get back to you soon. So guys, just to summarize this part. So there are 2 ways for capturing the terminating nature of a system. One was the method we learned 2 sessions ago when we created when we created a new create module, and then we changed some of the variables in the assign module and so forth. So that's one method. The second method is here. In this method, we created a schedule, and here we defined this schedule just because not only because of we wanted to capture the terminating system, but because the arrival rates were different in different hours of the day as well. So if I want to capture different arrival rates in different hours of the day, then creating a schedule is definitely the way to go. That helps you to put different arrival rates in different hours of the day. And then the very last thing I did is that I told the simulation when we are done, for anything after that, the arrival rate is 0, and that way simulation did not let any new customer to come in after that. And here, instead of picking a specific distribution, I just picked the time between arrival is based on the schedule, and I specified the name of the schedule, and that was it. So I have a question for you. Let's assume I tell you that in this call center, calls come to the system with the rate of, let's say, 45 calls per hour, and that's it. And it's the terminating system. So the calls are not changing in the rate of the calls that come to the system are not changing every half an hour. So for these 10 hours that I'm going to run this call center, I just have one fixed rate, 45 calls per hour. And it's still a terminating system. Can you tell me how are you going to capture that, the terminating nature, using this schedule?
I'll just use 10 hours of constant rate, and then I'll add one more row at the bottom saying 0 incoming calls for the next 5 hours or something.
Exactly. So if you just run a barbershop, supermarket, any terminating system for 10 hours, 20 hours, and so, and the arrival rate during that time is the same, no worries. So still define a schedule. And here, just say that, for the first 20 hours, for example, I'll have 45 people, 45 rate per hour, or 45 entities per hour for the first 20 hours, and then add your very last line, which is this one. And just say for an hour after that, or 2 hours after that, doesn't matter, the arrival rate is 0. And in that way, you still consider this as a terminating system, because after that 10 hour, 20 hours of the simulation with that fixed arrival rate is done, then the simulation is going to use this arrival rate for the rest of the time that the simulation is going to run, until every customer that is in the system gets up. Okay, so still you can use the schedule method even if your arrival rate is not changing in different parts of the day or hours of the simulation. Okay. Give me 1 second, check the chat. Yiding, do you want to share your screen so I see what's going on?
Yeah, I got the same error code as you had before. I have the same schedule name and entity type.
Can you check your schedule? Okay. That's correct.
And when I run the simulation, still got the error detect at the 726.
That shows the customers are still coming to your system.
Can you check your rejected call set?
Which part?
Stop. Go to the set. Go down.
Do I need to add like 3 more?
No. Can you go to your schedule again?
For the arrival schedule?
Yeah.
It's half an hour. Duration is correct, I think.
So I need 1 second, shouldn't? Let me get back to this, and after I finish this part, I want to get your model. Email me your model. Let me take a look.
Okay, sure. Thank you.
If I get the same error in my computer, sure. And then, okay. Okay, so save that. And then one more thing that we want to do on this model before we move on to the next part is that I also want to calculate the working process for the calls that come back to this. So the technical calls, remember I said 4% of them go out for further research. And I want to count, when they come back to the system, I want to know the working process or the number of calls that return from outside and they are in the system and they have not been answered yet, or the answering has not been finished yet. So when the calls come back to the system, I want to count how many of type 1, type 2, type 3 return call I have. Okay, so let me see. And in that, give me 1 second. Someone type something in the chat. Let me just see what's good. Somehow I cannot see the chat. Is there anything, guys? Is there any question? Oh, here. I have deleted the total. Yeah, that's fine. Guys, just please follow. I have a couple of things in the chat. Just please, can you just follow with me with everything we have? I'm talking about. So we deleted the previous working process for the all the calls in the center. I don't need that. Okay, so just keep your model. Do not change anything. Just follow everything I say. Okay. So here, I just want to calculate the total working process for the calls that enter, that the technical calls that we send out, and then they come back to the system. So what if I want to calculate working process, where do you think that is the right place to add, to increase the variable working process for the calls that leave the system and come back? Where is the right place to increase the working process variable? So here the calls leave the system, right? The calls leave the system, and then we put the delay module when the calls go and get the out of office research. Let me just increase it a minute so you see. So the calls leave the system, so they get the out of office research, and then the calls come back, and then we decide on which type of product they are, and then who was the technician who looked at their product and so forth. So where is the right place for me to start increasing the variable that calculates working process only for the calls that left the system for a research center to a research center and then they came back?
So you could do it right before, you could put the decrease work in process either between define product type and delay of offline research.
Yeah. So this is, for example, one place that we put, because here the call has come back from outside. So if I want to calculate the working process of those calls, I can just put an assign module here and just say, okay, at this point, increase the working process variable that is going to count these type of calls for me. So let's put an assign module. If you don't have enough space here, just put an assign module on the top and then add. So I'm going to do that. So you don't need to move things. So here, for example, I'm going to delete this connection. I'm going to say, Okay, so you can do that as well. You don't need to move all the modules to the right to create space for this one. If you don't have enough space, just put a module on the top. If you have a space, just put it on the row, on the same line. So what is going to happen in this module? Here, I wanna increment take call increment returned take call work in process. Okay, so that's the name I gave to this assign module. And here I'm going to add. So here we can create 3 different variables to count these 3 different working processes for product 1, 2, 3. And that's perfectly fine. And you can do that easily. What I want to do today for the sake of learning is to define a variable, a one-dimensional variable. So a one-dimensional variable is like a vector. So if you have 3 variables in this vector, so it goes index 1, 2, 3. Okay, so with this one-dimensional variable, all of them have the same names, whatever name you assign here. So here I'm going to give them a name, and I'm going to call them returned calls, returned take calls work in process. Okay, and now what is the index that we used for this what is the index that we use for this variable? Is there any guess? So now I define a variable that is one-dimensional, and the name of this vector is return take call work in process, and this vector has going to have 3 elements. One, index 1 for technical call type 1, technical call type 1, index 2 for technical call type 2, index 3 for technical call type 3. How can I tell the simulation that which, for example, let's go back here. So let's right click and pick build expression. Here, click on the attribute. And remember here in the attributes that we defined, there was a take call type. And one of the questions at the start of the class was that, why even did we define take call type in previous session? And in the technical call type, after we decide that an entity is product type 1 or product type 2 or product type 3, we assign this attribute and we gave it value 1, 2, 3. So now I'm going to basically use this entity type, this attribute, take call type. So this is going to be the index that I'm going to use to specify which row of this vector I'm referring to. Okay. So now, how do I want to change the value of this variable? If it was just one variable, remember how we would do it? We say, okay, just increase this variable by 1. That's how I would increase the one variable and save it in the same variable. That's how I would increment work in process by 1. However, this is not just one variable. This is an array of variables, and this array has 3 elements, index 1, 2, 3. So I have to tell the simulation which index should be increased by 1. Because if it's a return call, which is for product type 1, then I want to do that. If it's for product type 2, I want to do that, and so forth. So the way to tell the simulation is that here, I'm going to use in parentheses, in front of the variable, I put take call type. That's the attribute value that these entities are carrying with themselves. So when an entity comes through this line, so let me press OK and press OK one more. When an entity comes through this line, it's sent out to the out of office research center, and the entity is back. And now entity goes through this assign module. So entity is carrying an attribute that I assigned earlier. I defined the attribute technical call type, and I put value of 1, 2, and 3 right? So this entity is carrying this tag with itself. So when the entity gets to this assign module, the value of the tag is there. So when the entity is, and if the entity has the tag of 1, then I'm going to increase the first element of this vector by 1. If the entity has the tag of 2, I'm going to increase the second element of this vector by 1. And if the entity has the tag of 3, I'm going to increase the third element of this vector by 1. Okay, so that way, instead of just defining 3 different variables, we can assign just one variable that is one-dimensional, and the index of that dimension is in this attribute. If you look at the type, there is also one other option, 2D, and that's the scenarios when the variable has 2 dimensions. And for example, based on 2 characteristics, you want to assign some values. So based on the technical call type and maybe the type of customer, then maybe some calls are VIP, some of them are regular. So then in that scenario, you want to assign maybe a 2D variable. And then you say the indices for one index is technical call type, and for the other index, for example, is the customer type. And then based on these 2 indices, you decide which element of that matrix has to be increased by 1. Okay, so if it's one-dimensional, it's an array. If it's a 2-dimensional, basically it's a matrix. Okay, so press OK. Everyone is clear what is happening here? Press OK. Make sure to save, guys. And then when we answer the customer comes in, so the calls come in, so they are now in the system. We are going to answer the call, sees the agent, sees the line, answer the call, and then release all the resources, and we are done and we are good to go. Now we have to find a place or find a location where we can decrease the working process variable for number of calls in the system. So where is the right place for me to decrease the working process for these calls, for these returned calls that I'm talking to?
We can do it right after release tech agent 1, 2, and 3. Just create another assign module there.
Yeah, so we can just do it here. And I'm going to delete this line as well. When the technical call is done, no matter which type, I wanna all of them first go through this assign module, in which I'm going to decrease the working process by 1, and then from there they go through the record and exit the system. Okay, so what I want to do in this assign module, I want to decrease return call. Okay, so I'm going to decrease return tech calls and add variable is going to be one-dimensional. Variable name is return tech call work in process. Right. Let me just make sure I return tech call work in process. Only return tech call work in process. What is the attribute that I'm picking as an index? You can type it, but I personally prefer not to. So I always go here and just pick it from the expression, and the attribute name that had the index was tech call type. And what I want to do here is to say returned call. Can I just say return call tech types -1? Is that correct?
No, you have to index via the tech call type.
Exactly. If it was just a simple one variable, I could do that, but here it's an array. So here I have to specify the index of the array. So return take call work in process, take call type, which is the index, -1. So if the take call that is leaving the system is type 1 product, the index is 1. So that working process will decrease by 1. If it's the index is 2, it's type 2, the index is 3, it's type 3, and the corresponding variable will decrease by 1. Press OK. I forgot to mention that we have to go to, when we define this variable here, right? So when we define this variable here, we define the name of the variable, and automatically, like previous scenario, even if we did not go to the variable data module and we created this will automatically be created in the variable data module, right? However, the simulation does not still know that the dimension of this variable is 3. So that's the error I got. So what we have to do is to go to the variable data module, and here you see I have return technical call, and in that one you put number of rows 3. Okay, and then the simulation knows, I can delete this. Then the simulation knows that this technical calls, the variable that you define and automatically was created here, has 3 rows. Okay, you don't want to specify the number of columns 3, so it's 3 rows. So it's just one dimensional, so the number of rows is 3. Okay, so basically what happened is that in this assign module, when I wanted to increase the working process, I define a variable here right away, no problem. We could do that in all the assign modules. If you want to create a variable right in the assign module, that's absolutely fine. The variable will be automatically created in the variable data module. No problem with that. And then I increase the variable, I assign the index and so forth. However, if it's just one variable, it's perfectly fine. If it's a one-dimensional or two-dimensional variable, one more thing that we have to do is to go back to the variable data module, pick that variable that you define, and tell the simulation on how many rows or how many columns do you want this variable to have, so that the simulation creates that, assigns the vector size and everything to the variable, and then you're good to use it in the simulation. Okay, so it's good for you guys to see the errors, because yeah, here in the class we create the model, so for most of the times, 9% of the times, we go throughout everything without the error, but this is not the case for the exam or for the project and so forth. So, and the error messages are actually, most of the times, are good, and they help you enough to be able to know what is going on in the model. So it's actually good for us to sometimes see some of the error messages, and then you read it, and then you go back, and then you figure out what is going on, because that's basically the debugging that I'm sure you guys would need to do for the exam and for the project. I'm pretty sure you guys are doing for the homework too. Okay, so let's press OK. So now, again, we have everything. We have these user-specified counters and so forth. We can see what is going on in the simulation in terms of when the calls were rejected, in terms of the waiting times of the entities and so forth. So we can do all of that. So, however, we just defined 3 variables for work in process, right? And here you see we have all the work in processes, the ones that simulation calculates. We have it for the technical call, type 1, type 2, type 3, and so forth. We defined 3 new variables for technical calls that go out and return to the system. Is there any way I can find the value of those variables here? So what if I want to know the working process of those returned technical calls that we just calculated? I cannot get them directly in the report, right? We can create so many variables in the model, but the simulation is not going to generate the results of all of those. So the ones that we see here are some of the counters or some of the statistics that we define. For example, some of them are some of the things we define in the records: attempted calls, completed calls. These are some of the counters we define. So we see those as user specified, but nothing else. So if we define something in the records modules, we see them. If we define something in the statistics module, we see those as well. Okay, so if we want to see the number of rejected, the working process of the return calls, then let's go to advanced process and statistics. Okay, so in the statistic, I want to see the working process of return calls. So let's say I say that's the stat of return call 1 working process. So return call type 1 working process. And we talked about this in the past a couple of weeks ago, but I want to see if you guys remember. If I want to calculate working process or report anything related to working process, what should I pick from here? Is it a counter? Is it a tally?
I think it should be time persistent.
Why?
We want to see how busy, how many working progress there are in a given time.
Exactly.
So if the system is idle for a long period of time, we want to take consideration to that.
Exactly. So if I just say counter, counters just add 1 to a variable, nothing. If I say tally, tally just keeps the average of those numbers, maximum, minimums, like simple average, okay? However, if, for example, I look at my working process and when I look at the system for 10 minutes, and maybe for 9 minutes, there is no working process, and for 1 minute, there is one working process in the system, then I shouldn't just add 0 working process plus 1 working process divided by 2 and report, oh, working process in the system is 0.5. No, I have to take into account that the fact that the 0 working process was observed for 9 minutes out of these 10 minutes. And one value with a 1 number for working process was observed just 1 minute out of these 10 minutes. So I want to consider the time weight into account when I calculate the working process. Okay, so because of that, we pick this statistics as a time persistent statistic. So when the simulation calculates the averages and all of that, the simulation knows not to calculate just a simple average, add them all, divide by the total. The simulation automatically knows it's the time persistence, so it will consider the time as the weight factor for these numbers that we observe for the working process, so that it gives more time to 0. It gives more weight to 0 if 0 was observed for 9 minutes out of 10 minutes, for example. So pick the time persistent because it's working process. And here in the build expression, we can go find the variable. So the variable that I want to use is return take call working process. And here I just want to, for example, see the statistics for the first element. So I put 1, that means the first element of this module. The first index of this vector, the first index of this vector, return take call working process, the first element.
Professor, could you go over that part one more time? I'm sorry.
No worries.
I'd missed it.
No worries. The time persistent as well?
No, just the expression. I apologize.
Yeah. No worries at all. Ask questions. So the time persistent is fine. So I want to calculate the time persistent at counter or statistics. So here I just right click, build expression. And remember this thing that I want to calculate this time persistent statistics of is a variable, right? So I click on the variable and the current value. And here you have the list of your variables. And the ones that I want is the return technical call working process. And here I'm picking, for example, the first element. I want to see them separate. So here I calculate the return, the first element or the first index of this vector, right? Then press OK. So let's do the calculations for the second element and the third element.
Professor?
Yeah.
Does the arena array start at index 0 or index 1?
I think behind the scene is, I think, index 1. I have
I see. That makes sense. Thank you.
Yeah, I think with the 99% index 1. I believe. Yeah, here I'm sure it's index 1, 2, 3, but I'm just thinking behind the scene, yeah. Because I have seen errors that the index starts from 0 and then it gives error. So it's index 1, 2, 3, and then so. Good question.
I have one other quick question about time persistence statistics. Is
Go ahead.
the reason that Arena doesn't default everything to time persistent, that it's more memory intensive than a tally or a counter?
So let me first make sure I understood your question. So you asked basically, how do we know one statistics is a time persistent one and one is not? Is that the question?
No, it was a little bit more about the design of Arena, because I understand if we need to know the weighted average over time, then we use a time persistent statistic. Did Arena provide these other types of statistics mostly because a time persistent statistic requires more data collection, and so it's more memory and processor intensive?
Yeah, and also because not everything is time persistent, right? So for example, if you want to know, if you want to know cycle time, right? So we learned, for example, how to calculate the time of arrival of entities, and then also how to calculate at the end when they leave the system, how to calculate the time that they stay in the system, right? So at the end, if I just want to report the average of the time in the system for all these entities, and the maximum and minimum of those numbers, so that's a simple tally for me. So just get a bunch of numbers, report maximum, minimum, average, normal average. However, for time persistent, you're right. So it's not just keep the value of this working process variable or save the value of this working process variable. Save the value and also the time that the system stays with this value, so that we can use the time later as a weighting factor when we calculate the average. So that's what's happening there in this. Did I answer your question?
Yes, thank you.
Are you sure?
Yeah.
Okay, great. I wasn't sure exactly if I understood your question. But yeah, so those are basically the design of the arena behind the scene, as what do I need for each type of statistics, and then when I pick time persistent, it knows what to collect for that variable and how to do the calculations at the end. If something is tallied, the calculations is different, what he collects is different, and counter and so on. Okay. Okay, so we defined 3 statistics for return call type 1, type 2, type 3, and they're time persistent. And then if I run the simulation again, so you see here my simulation ran for 615 minutes. So now if I go to user specified, here I have time persistent statistics too. And if I click on that, then I see these values for return call type 1, type 2, type 3, work in process. Okay, and you see these values are small, obviously, because only 4% of technical calls, which itself was 70% of the calls were technical calls, and out of those, only 4% were out for additional research. And even when they came back, like now we have to answer them. So obviously the working process of the returned technical calls is not much. So it's usually an average of 1 and 0, and most of the time it's 0. And that's why the average that we see here is this number. So that's why you see the minimum possible value is 0, and the maximum that we have observed is 1. It's like that. At least it tells us for this 10 hours that we ran this call center for, there wasn't a situation when we received 2 return technical calls together. It doesn't mean that it cannot happen, but at least for these 10 hours, it didn't happen. That's why our working process is low. But however, the reason I mentioned this was that, or the reason that we went through this example was that I wanted you guys first to learn how to use variables as an array, a 1-dimensional or 2-dimensional array, to define working process or anything that you need. And then also know that we can define all these variables in the model, but they don't appear in the report automatically. If we want to see the value of some of these variables, we have to define some statistics based on these variables, because what we see at the end in the model, in the report, are what we define in the reports, the attempted call and things. So those are some of the basically statistics that we see, and then whatever we explicitly define in the statistic module, those are that we see in the user specified statistics. Okay, so save that. So we are good with this one. This is model 5.2. What I want you guys to do is to please save this model as a new model in the folder for week 10. Are we in week 10?
Yes, we are.
Okay, so save it as a new model in the folder for week 10. And and this is going to be model 5.3. Yeah, this is going to be model 5.3. And at the end, you can say staffing, because that's what we are going to. I already have one staffing, so I put it version 2, but you guys just put staffing. Okay, so this is going to be model 5.3, and at the end of the name, just put staffing. So save it in the folder for week 10. And so again, like week before, we are going to just continue building on this model and just learn new techniques and so forth. So in this model, 5.3, we want to learn a couple of things. So first, we want to learn how we can potentially calculate the cost of these resources, or the cost of everything in the model. And also, if we want to add some new staff, where is the right place when we should hire the staff? So let's run this one more time before okay, so I went to 650. So the call center stayed 15 more minutes to take care of customers that were already in the system. So now let's go to user specified counter. So here, as you can see, we have period 1, period 2, period 3, period 4, and then period 5, 6, 7 are, so these are our 3, so hour 1, hour 2, hour 3, hour 4, hour 5, 6, 7, where we have some rejected calls. So these are probably some of the hours for which we may want to hire more staff and see what is going on. Okay, so that's why we define this, for example, periods, the rejected calls per hour, so that we see in which hour we have more rejected calls, so that we can hire more staff during those time periods. Okay, so we want to do that as well. Okay, so tell me, what are the sources of cost in this model? You are working as a consultant for the manager of this call center.
The call center staff.
The staff is one. What else?
You could look at the missed revenue on the rejected calls as a cost in a way.
That's one, two. What else?
How many
Exactly. How many trunk lines did these phone lines, their cost? And anything else from the customer service perspective? In terms of how long they stay in the line. So usually in the service industry, we do consider that as well. So how long the customers waits in the line is a basically implicit cost of the customer service, because if I wait in the line too much, after once or twice, if this happens like in once or twice when I call this company, I just give up and just change my service provider, right? So there is then some implicit cost related to the waiting time of the customers in the system. If the waiting time is greater than some specific numbers, then any minute greater than that will impose some cost to the company. And actually, a lot of these companies, their marketing department and so forth, they have already calculated those threshold values. So they know that, for example, for the calls, for the customers that call a bank to maybe have some issue and have some issue with their account, they are okay if they wait, let's say 4 minutes, but anything over that causes some unsatisfaction, and that may lead to the loss of the customers and so forth. So they calculate this cost related to this implicit cost related to the long waiting times in the system. So for this call center also, we have the cost of the staff, we have the cost of the the trunk lines, and also we have the cost of these additional waiting times above the threshold of the customers, and the waiting times above the threshold of the customers, and also the cost for those rejected customers that we couldn't provide service to. Okay, so we want to see how we can basically do some calculations related to those. So here, yeah. Okay. So what we have here is in terms of the technical support stuff. So these are the costs that are fixed, okay? So, and we want to calculate the cost per week, okay? We are running the simulation model and we want to calculate the cost per week. So we are running the simulation model for 1 day. That's what I mean. So we are running the simulation model for 1 day, right? 10 hours till everyone is out. However, at the end of these 10 hours, I want to get a sense of the cost for 1 week. So for the technical staff, if you remember, we had 11 people. All those names that we defined, there were 11 people. 8 of those people that are working 8 hours per day, per person, are going to get $18 per hour. And this is just for 1 day. And remember when we defined the schedule for the technical staff, we went through 11 hours. That's fine. But however, we defined that 11 hours of a schedule just because we want to run the simulation for 11 hours. But the working of each staff is 8 hours. So each one of them was working only 8 hours during that 11 hours of the schedule. They were not working in the rest of them. So the hours in which they are working is actually 8 hours that we define in those schedules. Per person, we have 8 of them, which are going to be paid with the hourly rate of $18 per hour. So that's for 1 day, and we have 5 days per week. So that's this much money for the cost of this staff in a week. And then, so that was just 8 of those technical staff. I also have one of them, which is going again to work 8 hours per day, and this person is going to get the salary of $20 per hour, and this person again is going to work 5 days a week, and the total value at the end of the week is $800 for that person. And we said we had 11 technical people, right? So these are 10, These are 9. So the other 2 are going again work 8 hours per day, and they are going to get paid with the rate of $22 per day, 5 days a week, and the final value is 1760. Okay. So again, there's nothing tricky about this. These are just some values that we know, that there are 11 technical staff, 8 of them are paid this much with this rate, 1 of them is paid with this rate, 2 of them is paid with this rate. They are working 8 hours a day, 5 days a week. So these are the value of the cost per week. So nothing tricky at all. Then we also had sales staff. And for the sales staff, we actually had, we defined the sales schedule, right? So in one day, if we calculate all the schedule, how many people work for how many days and so forth, we have 45 hours per day for the whole sales staff. So 45 hours per day, and we are going to pay sales staff $20 per hour, and they're going to continue 5 days to work 5 days per week, and the whole thing is 5400. Okay, so for the technical staff, for the sales staff, what we did, okay, yeah, for the sales staff, overall in a day we have 45 hours per day. So like when we sum up the number of staffs and the hours of working of each one of them, at the end we have 45 hours per day, and each hour we pay these people $20, 5 days a week. That's this much of cost for the technical staff. And if I add the total or the fixed staff cost, so that's the one we already have, that's 12,820. Okay, so that's the one that we already have. Now, this is the cost of the current system. What we want to do now, remember we look at the calls lost per hour, and we saw that we were okay for the first 4 hour 1, 2, 3, 4, but then for hour 5, 6, 7, and 8, we wanted to add more staff because we had some rejected calls. Okay? So we want to see how we can do that. So now let's go for the staff. Let's go to the schedule. Okay, and here in this schedule, let's look at the sales schedule. Oops. So I wanna look at the sales schedule, okay? So in the sales schedule, if you look at it right now, we see in the first, so the time unit is half an hour, right? So in the first hour, we have 1%, in the second hour, 3, in the next hour and a half, 4, and then, wait, duration is, and then in the next hour, we have, in the next 2 hours, we have 5. Now, what I want to do here is that we said we want to assign, we have a lot of lost calls in the hour 4, 5, 6, and also I want to add more personnel to hour 7, right? So what I want to do here, instead of just having this person working for 5 people for 2 hours, so I'm going to change this to 5 people for 1 hour, because I want to add more people to the next hour. So what happens right now, guys? Let me explain this one more time. Okay, so this is hour 1, right? 2, half an hour. This is hour 2. And then this is hour 3.5, right? And I'm good with everything till the end of hour 4. So if I want to make the first 4 hours without any change, what should I do now? For so far I am hour 1, 2, hour 3.5. What should I do now? For this next one, I'm going to change it to duration. I'm going to change it to 1. Okay, so what happens now? First hour, second hour, 3.5, 4. So for the first 4 hours, I'm okay. I'm not changing anything. Good. In the next hour, or in the next half an hour, which was here, but I removed it, remember? Here, there were 2 half an hour. I put one of them here, but still there is 1 left. So for that one, I'm going to add something here at the bottom. And then move it to the top later. For that one, I'm going to add a new capacity. So I'm going to say my capacity is going to be 5 people plus new cells. Okay. And how long? For 1. And I'm going to keep control arrow up till I get to this one. Okay, so let me tell you what's happening here. Let me press OK. Go to the variable. Okay, let's do this here, guys. Come to the variable and define a new variable here. Let's call it new cells. Okay, so this new cells, yeah, new cells stuff. Okay, so new cells. So this is a new variable we define. Why do we define this variable? Okay, let's do that. So first, define the new, go to the variable, define new cells, okay? Now then, let's go to the schedule. Let's double click on the schedule, cells schedule. So what I wanna do here is that for the hour 5, 6, 7, 8 of the simulation, I wanna add more staff to the sales people. So here, remember the first one says, for the first 2 half an hour, I have 1 staff. For the next hour, I have 3 staff. For the next hour and a half, I have 4 staff. For the next half an hour, I have 5 staff. And then for the next half an hour, I had 5 staff. That's why I had 5 and 5, and then the unit of time was 2. However, I separated them because I want to give half an hour to the first group, which makes the first 4 hours of the day that I don't have any rejected calls and I'm good. So that way I make the first 4 hours of the day when I don't need to change my staff. I'm good with 1, 3, 4, 5 people. However, as soon as the hour 5 of the simulation starts, which is here, I not only want to keep my 5 people that are in the staff, but also I want to add more people. Instead of writing 5 plus 1 or 5 plus 2 or 5 plus 3, what I want to do, which is better, is to add a variable here and just say that the number of the capacity is not 5 people, it's 5 plus new cells, and new cells is a variable that I define. So later, if I go to the variable and change the value of new cells to 2, that means the number of staff is going to go to 7. If I change new cells variable to 3, the number of staffs is going to be 5 plus 3, 8. For how long? For that half an hour that was left. Okay, so that's what is happening here. You could just say, oh, instead of 5, I'm going to put 8. That's fine too, but if later you decide to change the additional stuff to 4 or to 5 or to 10, then you have to come and change these values by hand all the time, and you forget where was the place where I added some stuff. Was it in hour 3? Was it in hour 4? But if you write it this way, it's always clear that this is the time you need, this is the half an hour in which you want to add some additional stuff. And what is the value of this additional stuff that you want to add? It's in the variable new cells. Okay, so that's basically what is happening here. And then in the next 2 hours, in the next hour or two half an hours, again, I want to make sure I'm having some new stuff. So I'm going to keep it as 6 plus new cells. Instead of just 6 people, I'm going to 6 plus new cells because I want to add some stuff in the hour 6 of the simulation as well. That's hour 6 of the simulation. And in the hour 7 of the simulation, I also want to add additional stuff. This is hour 7.5. So this 3 gives me hour 7.5, right? So I'm just going to edit and just say, for this hour and a half, I also want to add additional stuff. Okay, so that happens. So now tell me for how many hours I have added additional stuff. So remember, let's go back to the top. For the first hour, I'm good with what I have. For the second hour, I'm good with what I have. For the next hour and a half, I'm good with what I have. For the next half an hour, I'm good with how many stuff I have. So these are the first 4 hours of the day, which we didn't have any rejected calls. We didn't want to change anything. Then in the 5th hour of simulation, I wanted to add additional stuff. That's where I kept this half an hour that I picked from here. And then in the next time period, whatever it is, I still want to add additional stuff. And then in the next time period, which is half an hour, I want to add additional stuff. So for how many hours I have added additional stuff so far?
For 3 hours.
For 3 hours. 6 half an hour, which is 3 hours. But I want to add additional stuff for 4 hours. So what I'm going to do is that so what should I do, Christian? If I want to add additional stuff for 4 hours, I already did 3 hours. So I want to add it for 4 hours. What should I do? How should I change the rest?
You could add, you could add new sales in 5.1. Or I'm sorry, in 3.2, I apologize, for another hour. But I'm not sure, is this supposed to be in order?
Yeah, so these are the orders we have. So up to now, we have into hour 7 of the simulation. The hour 8 of the simulation starts here, which we already have 6, and I want to add more people to that.
Well, you could break that 6.3 up into 2 separate times where you have however many salespeople in one section for 1.5 hour, and then the other 2, you could do however many people you need plus new sales.
I keep these new parts for 2 units because this is 1 hour. So everything right now is 4 hours, remember? So the first 3 rows that you said was 3 hours, right? That's hour 1 to 3 when I added additional stuff. I want to add additional stuff to hour 4 as well. So I keep this for 2 units of time, 6 plus additional stuff for 2 units of time. So that makes it 4 hours. But if you remember, the original one was 6 plus 3 time units, right? So,
correct.
So I add another 6 with 1.5 an hour, and I just add it, and then I just move it to the, that's what's happening, right? So then this is the other half an hour left. Does that make sense, guys?
Yep, that makes sense to me.
Nothing, like I know it may be confusing, but it's not tricky. All you need to do is to just look at the time units here, and remember that when we look at the number of rejected calls per hour, for the first 4 hours, we were fine. We need to add more staff to the second 4 hours of the simulation. And that's why I somehow changed some of this time units such that I can make up the first 4 hours without any change on the number of staff. I can keep still number of staff to 1, 3, 4, 5. And then in the next 4 hours of the simulation, I still keep the number of staff as they were, but I add more staff if I need. And then I keep I make sure these additional staff are just for the second 4 hours of the day, second 4 hours of the simulation. And for the rest of it, I'm still good to keep whatever number of people I have for whatever number of time I have. Okay, so that's what's happening here. So that way, it's a very good way for you guys to add additional staff for some part of your simulation. So this is a perfect way to do it. Define a variable, new cells, whatever, and just add this variable to the number of staff for part of your simulation time. And that way you can increase or decrease number of staff if you need to for some part of your simulation time. And if you need to change it, all you need to do is to just come back to the variable and say, oh, in terms of the new cells, I actually have 3 more new staff for cells. I have 5 more staff for cells. And so all of those in the schedule are going to change automatically. Make sure to save, guys, before we leave, before we go forward. Okay, so we did that. One more thing that one additional thing I want to do is that for the, remember here for the sets, we defined 3 sets for product 1, 2, 3. Now, I want to assign one person. I want to hire one more person that is only can answer product type 1 question. I want to hire one more person that can handle product type 2 question, and one more person for type 3 products, and one person that can answer all of these type of questions. So basically I want to hire 4 more people which are in charge of technical support calls. However, these additional people, I don't want to hire them for the whole day like what I had here, or what I had in this schedule. I don't want to hire them for the whole day. So I just want to hire them for 4 hours in the day, and that's the middle 4 hours of the simulation time, or middle 4 hours of the day when I have more rejected calls. So I want to hire this additional staff not for the first 4 hours, only for the middle 4 hours, and then not for the other 3 hours of the day as well, just for the middle 4 hours. So how we are going to do that. So let's go to the resources and let's define 4 new resources, because I want to hire 4 people, 1 for each product type, and 1 which can answer all the product types. So let's call the additional staff that I'm going to call or hire for give the right name. Okay, so let's call the person that I'm going to hire for product type 1 as Larry. You can give it any name or just product type 1. So Larry, and I'm going to say Larry P1, just to remember this was the guy for product 1. And that's it. I'm going to assign another resource, and I'm going to call it Moen. Let's say this guy is going to be in charge of product 2. I'm going to assign another resource, define another resource. I'm going to call this Curly. This person will be in charge of product 3. And then I'm going to also define one new resource. I'm going to call it Hermes. And this guy will be in charge of all products, or can answer the question for all the products. Okay. So I defined these 4 staff, and then I'm going to, obviously, how should I tell the simulation that these 4 staff are going to just work for the middle, for hour 5 to 8? how should I tell the simulation? I'm going to define a schedule. Okay. So I'm going to define a new schedule. I'm going to call it Larry schedule. So in this schedule, and I can keep it as hour. So I don't want this person. So let's just, for the simplicity, just keep it as a half an hour so that we don't get confused. So I don't want this person to work for the first 4 hours because I don't need to hire anyone for the first 4 hours. So then the value of capacity is 0 for 8 half an hour, which is the first 4 hours, right? And then I want this person to work for the next 4 hours. So I want this person to work for the next 8 half an hours, which is the next 4 hours. And then I don't want this person to work for the next 6 half an hour, which is the next 3 hours of the day. Remember, for the schedule that we defined for the technical staff was 11 hours. So the first 4 hours, the second 4 hours, the next 6 hours. Okay. So that's what we define. Okay, so now just look at this. So for Larry that I want to, so let's say Larry is a typical name for the people we want to hire for answering the calls related to product 1. I just call them as Larry. And I want them to work for the second 4 hours of the day. However, what if I want to hire more than one person? What can I do here? What if I want to hire more than one person here? And that, how can I do that? So if we go to the variable here, I can define a new variable. I can call it new tech 1. This is the new technical staff that is going to help with product 1. Okay. So then when I come to this schedule, when I go to the schedule of Larry, instead of just having one person to work in the second 8 hours, in the second 4 hours of the simulation, let me just copy the name. Here. So if I go back to the schedule of Larry, instead of just having one person to work in the second 4 hours of the day, I can just say, instead of value, I can just say new tech 1. Instead of just 1, I can say new tech 1. Then here, the value of this variable would be number of staff that I will hire. And here in the variable, I have the luxury of changing the new tech 1 to 2 people, to 5 people, to 10 people, as many people as I want to hire to be in charge of product 1 questions. So in my schedule, and the Larry's schedule, which is just a typical name for all the people that are capable of answering questions related to product type 1, instead of just having one person that is going to work for the second 4 hours of the day, I'm going to put this name of this variable, new tech 1, and in this variable, I'm going to save how many people I want to hire that are going to help with the first product. Okay. So we did that, and I'm going to do the same for product type 2. So I'm going to define a new variable for new tech 2, and another variable for new tech 3. And in this schedule, I'm going to define a new schedule for MOE who is a representative of all the people who are in charge of product 2. Remember, we defined the resource for that. And the unit of time, half an hour. So for the first 4 hours, we don't want to hire anyone. For the second 4 hours, we want to hire more technical staff. And then for the last 6 hours, for the last 3 hours, we don't want to hire again anyone as well. So that way we hire just these new technical staff for the product 2 in the second 4 hours of the day. And then I do the same. This will be Curly schedule, and she was the person in charge of product 3. So here, again, I say that in the first, I don't want to hire anyone in the first 8 hours. I'm going to hire more people in the next half an hour or 4 hours, and then again no more person in the next 3 hours. Okay. And then so I defined 3 schedules for Larry, Moe, Curly, who were in charge of who are the new staff. So Larry, Moe, and Curly basically are just representative names. So that doesn't mean just one person. So this just defines the schedule of the staff for product type 1, the schedule of the staff for product type 2, the schedule of the staff for product type 3. And for all of them, we don't want to hire anyone in the first 4 hours. We want to hire some people for the second 4 hours and no one in the last 3 hours. Okay. So if I want to change the number of staff that I'm going to hire, I can go to the variables and change the number of technical staff type 1, type 2, to 3 that I'm going to hire. For now, I'm not changing any values. The default value of all of these new technical staff is 0. And remember, I said also we want to hire some people which are in charge of all type of products. So add a new variable. Let's call this new tech all, which means this person is all the technical calls. And then let's go to the schedule and define a schedule for this all call schedule. And I'm going to, again, do not hire anyone that can answer all the calls in the first 4 hours. I want to hire some people. Again, we can click on I can either just press OK, go copy the name from variables and come back here, or I can just say build expression, the variable, the current value, which variable, new take all. For the next 8 hours, and 0 people in the next 3 hours. Okay, so I defined that the same schedule for this person that is in charge can answer all the calls as well. So now let's go back to the resources. And for Larry, which is in charge of product 1, let's assign the right schedule. So based on the schedule, and what is the schedule name? So it's Larry's schedule. And for the rule, let's pick ignore. That's what we decided in previous session. So let's just do that as. And for Moe, which is in charge of product 2, I want it to be based on this schedule 2 as well. And this schedule is the one that I defined for Moe. And for Curly, I want to be based on schedule. And the name of this schedule is here. Make sure it's ignore. And finally, Hermes, I want to be based on the schedule as well. And what did I define? All call a schedule, I call it. I could say Hermes schedule, but anyway, all call a schedule. Ignore and press down. Okay, so what I wanted to do was that since in the hour 5, 6, 7, 8 of the simulation, I had some rejected calls. I wanted to hire more staff in those time periods. So for the salespeople, what I did was easy. So I went to the sales schedule, and in those 4 hours, I just added a new variable. I said 5 people plus whatever is in this variable. And in this variable, basically, I can add additional staff to these 4 hours. That's what I did. And I define new sales as a new variable, so I can just change the value of this variable to 2, 3, 4, whatever, and 4 new people will be added in this 4 hours of the simulation. Nothing to the first 4 hours, nothing to the last 3 hours, okay? So that's what I did for the sales. For the technical support, the story was a little different. The technical support was, first of all, if you remember, they were just separate people. I didn't say, oh, salespeople, and there are like 6 of them or 7 of them, and then things like that. So for the tech people, the story was different. I defined these people separately. And then I want to hire some people who can answer product 1, some people who answer product 2, some people who answer product 3, and some people who can answer all the products. So what I did, I went to the resources and defined 4 resources, a representative of people who, so this basically name of the resource shows people who can answer product 1, product 2, product 3, and all of them. Okay, so I just gave them some name. And then, so these people are working based on what schedule? I defined the schedule here. I said these people are working to only work for 4 hours during the day. So no work in the first 4 hours, work in the second 4 hours, and then no work in the last 3 hours. However, I don't want to hire just one additional person. What if I want to hire 2, 3, 5, 6, 7, 8? Like, so instead of just entering 1 as the capacity, I put this variable, new tech 1. So what I did is in the variable, I defined 4 variables, new tech 1, new tech 2, new tech 3, new tech all. These are the number of the additional tech staff that I'm going to hire that can answer technical products. So in this schedule, instead of just saying 1 person or 2 person or 3 person, I put this variable. So all I need when I want to hire more people, all I need is just to go to the variable menu and just say, oh, I have 2 people or 3 people or 4 people as technical staff. Okay, so we did that. There is one thing left to do. Can you tell me what is that in terms of the resources to work properly? We define additional resources, we assign the schedule, everything is fine. But
assign them into the sets, right?
go ahead.
Into the relevant sets.
Yeah, exactly. Simulation still does not know these people are the ones that can answer technical calls, right? Because when I answered technical calls, I just use set 1, set 2, set 3. So that's it. And already I know which resources are in those sets. So simulation is not going to use these additional resources that I created. So then I have to go to the set and add these additional resources to these sets. So what I want to do now, I'm going to add here on the top, add Was it Larry? Larry P1. I'm going to add it on the top because Larry can answer only product type 1. So I want it to be on the top. And then for the Hermes that can answer all type of calls, I'm going to add it to the end so that I'm going to use it as the last resort. When all the resource that can answer only to call type 1 are already used, then I'm going to use Hermes. Okay, so I added then Larry on the top and Hermes at the bottom because Hermes can answer all the phone types, all the product types. And then for set 2, again, I'm going to add Moe on the top because Moe can answer only product 2. And then I'm going to again add Hermes. I'm going to add Hermes at the bottom because he can answer all the phone product types. So I want to just keep him then for the time I need him. And then for product set 3, I'm going to add and at the end I'm going to add Hermes. Okay, so now we should be good. Okay, so we did that. Now what we want to do is to calculate the cost. Remember here, here we calculated the cost of the fixed number of employees that we have. We are good with that. Now I want to calculate the cost related to these additional employees. And for that, I don't think if I put the values here. Okay, for the excess, for additional sales staff that we are going to hire, we are going to pay them $17 per hour. For the additional tech staff that we are going to hire, we are going to pay them $16 per hour. And for those tech staff that can answer all type of questions, we are going to pay them $17 per hour. Okay. So these are the numbers that we know. So now I want to calculate the additional cost of the staff. And I don't want to calculate it in PowerPoint because the number of staff is not fixed like the original version. These are additional staff that I want to add. So I'm going to play with adding 2 more staff or 3 more staff or 5 more staff. And every time I want the simulation to calculate this additional cost for me. So to be able to do that, I'm going to go to expression. And here on the expression, I'm going to define an expression that can just calculate this cost for me. So this is going to be new resources. And how I'm going to define it. Let's go to build expression. So basically what I did is that I define a new expression and here I press add and then this expression value popped up, but instead of just typing here, I'm going to right click and build expression, pick build expression because it's just easier to write here. So now, what do I want? I want to find number of new sales staff that I'm going to hire. And I want to calculate the cost per week. Remember the total cost that here I calculated for the original staff is cost per week. So here also I want to calculate the cost per week. So I find out how many new staff I need to hire. That's in the variable new sales. And then I'm going to pay $17 per hour to each one of them. One second, let me see this. And then $17 per hour, and I'm hiring them to work for 4 hours a day, and I have 5 days in the week. Okay, so number of staff that I'm going to hire, additional sales staff, I'm going to pay $17 per hour to each one of them. In each day, I'm going to hire them for 4 hours, and in a week, I'm going to hire them for 5 days. So that's the total cost of new sales staff for the week. Then I'm going to hire new tech. So for the technical people, let's just add them together because the cost calculations is the same. So then I can just do the calculation. So new tech 1, new tech 2, plus new tech 3. So these are the total technical staff, additional technical staff that I'm going to hire. For all these technical staff, I'm going to pay them $16 per hour. I'm going to hire them 4 hours a day, and I'm going to hire them for 5 days a week. And then the other additional staff that I have are the technical staff that can answer all type of the calls, new tech all. And for those, I'm going to pay them $17 per hour, and I'm going to hire them for 4 hours a day and 5 days a week. Okay. So that's the cost of additional technical staff or additional staff. And here, let's add, if I want to calculate the cost of additional trunk lines that I'm going to add as well. Okay, so then so it's not the cost of actually additional trunk line, it's just the cost of the trunk lines that we have. So if for each one of the trunk lines in a week, we pay $98, here I'm going to add, multiply that $98 by, let's go to the resources, usage, and I want this to be current number scheduled and trunk. So basically, let me just copy this for you in a Word file so that you guys see what we wrote. So this is what I saw. So new sales people, new sales staff, how much I'm going to hire, how many I'm going to hire, multiply by 17 hours per day, per hour, 4 hours per day, 5 days per week. And then for technical staff, 1, 2, 3, whatever I'm going to hire, I'm going to pay them $6 per hour, 4 hours per day, 5 hours per week. And then for the technical staff that can answer all the calls, I'm going to pay them $17 per hour, 4 hours per day, 5 days per week. And so at the end also, I added, if I pay $98 for the cost of the line for the whole week, Then MR trunk line gives me the number of trunk lines that I have in a week. And that just multiplied by 98 gives me the cost per week. Okay. So that's what I put basically in this expression.
Professor,
Yeah.
don't we have to do like order of operations in terms of like with parentheses and stuff in this expression that we just built? Like for the first part, like putting parentheses around each individual calculation cost.
I believe it does all the multiplication and all the multiplication and all the multiplication and then addition. But just to be on the safe side, yeah, just to be on the safe side, we can do that. New cells. Yeah, it does all the multiplications and then additions, but you can put the parentheses just to make sure you do it does the calculations and multiplications and summations and all of them correctly. So what I did is that I just put the parentheses around this. That's what I did. That's what I did. Okay, press OK. Press OK. Save. Okay, so this just calculates the weekly additional cost of resources for us. Okay, the next thing we want to calculate is the cost of wait time, additional wait times. Okay, so how do we calculate the cost of additional wait times? First, we have to calculate the additional wait times in the system. To be able to do that, we need to define some assigned terms. So far I calculated the cost of the fixed staff. Then I calculated then I added additional staff and I calculated the cost of the additional staff in the expression. Now I want to calculate the time the customers are waiting on top of their threshold and then calculate the cost associated with that. So let's see how we are going to do that. So for the calls related to the cells, okay, so pick that one. That's easy. Just they go through the sales calls and then they are done and they go through the rest of the process. So right here, I'm going to add a assign module right here in the middle. After I'm done with processing the sales calls and before they leave the system, I'm going to add an assign module right here, okay? And what do I want to do in this assign module? I want to assign for excess sales call wait time. So I want to calculate excess sales call wait time. So how I'm going to do it here? I'm going to add a new variable, and this variable I'm going to call it excess sales wait time. This variable, I just define it here. So as I'm defining here, it will be automatically defined and will be added to the variable data module. I don't need to go here and define it first and then come here. I can just define it here for the first time. It will be automatically added to the variable data module. So for this variable that is going to count the waiting time of these calls in the system, the waiting time in the system, how I'm going to do it. So whatever is in the value of this variable, I'm going to keep it, and for and add this, write it down and I'll explain in a minute what it is. So let's assume for the sales calls, the threshold of customers is 1 minute. They are okay to wait for 1 minute. For anything above that, they get frustrated, and that's an implicit cost to the company. So I say max entity dot wait time -1, comma 0. Okay. So what is happening here is that simulation defines this variable, and with this entity.waitTime, it's a built-in attribute in the simulation. Similar, remember, we define entity.type, entity.picture. Remember, we use those scenarios. So, or even we may have it here. No. So this is another one, entity.waitTime. It's a built-in attribute that calculates the waiting time of an entity in the system. So this, whenever we call this attribute, it calculates the waiting times of that entity in the system by that moment. Okay, so that's why I write this assign module at the very end when the sales calls have stayed in the system and those entries have been entered in, have been stayed in the system and have been answered. Then I call this assign module so that at the very end I can call this attribute and it calculates the wait time of the entity in the system for me automatically. And then I look at this wait time -1, because 1 minute is the okay time for the customer to wait. 1 minute is the threshold. Anything above that 1 minute is the one that is going to impose some cost. So that's why I put maximum of this and 0, because if a customer has stayed in the system, let's say for half a minute, there is no excess wait time in the system, right? So I don't need to have any cost for that customer. In that scenario, the wait time of that customer is 0.5, -1 is -0.5, and then maximum of -0.5 and 0 is 0. So for that customer, basically the waiting time that causes some implicit cost is 0. That's the whole idea of this maximum of waiting time and 0, because if the waiting time is above the threshold, yeah, then the maximum of that number and 0 is that number. But if the wait time in the system is below the threshold, so the maximum of that negative number and 0 will be 0. That means that customer will not have any cost for additional waiting in the system. So basically what this whole thing means. Okay. So that's what I calculate here. Whatever I have in the waiting time for each entity, I'm just going to calculate the waiting time and add it to this variable. And I just add it over and over and over. So this variable at the end will calculate the waiting time for all the entities, all the sales calls in the system, because initially it's 0. And then one entity comes, I calculate the additional waiting time for that and add it to this variable. And then the next entity comes, I calculate additional waiting time for that entity and add it to this variable. So at the value of this variable at the end of the simulation calculates the total extra waiting time for all the sales customers. Okay, that's okay. That's okay. Then I need to do that for the other call types as well. So let's create one assign module here. This is for the order status calls. And I'm going to, for the order status calls, remember there are two lines. One is the calls that do not need additional sales question, and one is the calls that need additional sales question. So for the calls that need additional sales question, just delete that connection and just connect it to the new assign module that I added, so that all of them go through this assign module and then to leave the system. And on this assign module, I want to assign access order status. Okay. Add. I'm going to define a variable. What I'm going to name this variable, I'm going to name it access order status rate. And what I want to do is to just get the same variable name and say that plus, again, max entity wait time minus, for the order status, the threshold is 2 minutes, so -2. So they are good to wait for 2 minutes, but anything above 2 minutes has some implicit cost. So for all the order status calls that come to the system, I want to calculate how much more time they stayed on top of 2 minutes, which is their threshold, and then add it to this variable that calculates the total waiting time for all the order status calls, and then that's it. Okay, so that's what I do here. Press OK, press OK. And then I also need to do that for the sales, for the technical support card. And for the technical support card, remember there was a point where 4% of them went to outside and blah, blah, and the other 96% of them were good and left the system. So for that 96% that were good and left the system, let's add another assign mod. Let's add one assign module. So this is for that 96% of technical calls that didn't go out and additional research, blah, blah. So they just left the system. So for those, I'm going to say access technical wait. And here, I'm going to assign. So the name of I put it assign access tech call wait, and then here I'm going to, for the name of the variable, I'm going to say access tech call wait. And what I'm going to do here is that access tech call wait plus max entity dot wait time. So for the technical calls, the threshold is 3 minutes. So anything above 3 minutes is going to be the additional waiting time that is going to impose some additional costs to the system. So then I calculate entity wait time, anything above 3 minutes, -3. I'm going to get that and I save it in the variable access tech call wait. Every time an entity leaves the system, if the entity has waited more than 3 minutes, I'm going to add that additional minutes to this variable. So at the end of the simulation, this variable calculates total wait times, extra wait times of the technical call people. Press OK, press OK. And I also have this group of calls that also need an assign. So I'm just going to add one assign to the very end here. Then these other technical calls, that 4% that went out and came back and I did everything right before they leave the system, I'm going to add another assign module. So in this assign module, I can also assign again access call wait. These are basically return take call. And this variable that I want to use for the take calls is the one that I already defined, right? So this is access take call wait, which I already have defined because I just used it. So I'm going to use this variable and then add -3, 0 and okay. So I just added these 4 assign modules for any take call type. As soon as we are done with that call type and we are ready to leave the system, then I added this assign module in which I calculated the additional wait time of that entity on top of a threshold. And we said the threshold for the sales calls is 1 minute, the threshold for order status calls is 2 minutes, and the threshold for the technical calls is 3 minutes. So anything on top of these thresholds is going to be the additional waiting times that is going to impose some cost to the system, and I want to calculate that. Make sure to save your model. Let me see, there's a question in the chat. What is the function of max in the expression? So the question is that what is the function of max in the expression? So basically, this is what happens. So let's assume an entity comes to the system, right? And we are here. For that entity wait time calculates all the waiting time in the system for that entity. So that's the waiting time in the queue, okay? The processing time or the delay time, those are not considered as waiting time. So these are waiting time in the queue. Or, I'll get back to it. Or, for example, if in a process, remember here, I can, here I can say value added, non-value added, transfer wait. If there is a delay in the system that I have defined it, not as value added, non-value added, but as a wait, that will be calculated in this attribute as well, okay? So this attribute calculates all the waiting times in the queue and everything else, every other delay in the system which we have specified as the wait type as opposed to value added, non-value added. All of them will be calculated by this built-in attribute in the simulation model. So, okay, so the question was that why do we use max? So here, let's assume one entity comes to the system and this entity has waited only 1 minute in the line, right? We set the threshold for the order status calls is 2 minutes. That means if that call in the system has waited 2 minutes before it gets answered, or total 2 minutes, we are fine. The guy is not worried or is not angry or nothing. If they wait in the system more than 2 minutes, that's where they get angry, and we are paying some implicit cost for anything on top of 2 minutes. So if the guy has waited just 1 minute, what this expression will return for me is 1 minus 2, right? So that's -1. So then I don't want to add the -1 to this variable that is counting total waiting, total extra wait of the customers. So if the customer has been in the system 1 minute, that's below the threshold of the customer, and so I'm good. So for this part, then it returns 1 minus 2 minus 1, and I look at the maximum of -1 and 0. So the system will return 0. That means for that customer, I'm not going to add any waiting time, any additional waiting time to order status variable. Okay, that's why we put the max, so that for those customers who did not pass their threshold in terms of waiting, we just pick 0 and add it to this variable. Is that clear? Okay, guys, make sure to save. And then the very last thing I want you, I mean, not very last thing, but one of the last thing I want to do is to go to the expression, go to advanced process expression, and let's calculate the cost of this additional waiting time, right? We calculated the fixed cost of resources, good. We calculated the cost of additional resources. Remember, we added this long expression. We added this additional cost of resources that we added. So let's define another expression in which we can add the cost of this waiting time. So cost of what I say is excess wait time cost. And here, what I'm going to add is, these are variables, right? What I wanna is the value of Excel's sales wait time multiplied by, so we are going to pay 81 cents per minute per day. So, okay, so I put this value, I will explain in a second how they are calculated. Plus order status. Oops, no. Multiply by 1.73 plus wait call for the technical calls and multiply that by 1.84. So this is what I put. The excess sales wait time variable multiplied by this, order status excess time multiplied by this, and tech call wait time multiplied by this. I'll explain to you in a second how these numbers were calculated. But basically, these are based on the information that I have in terms of these additional, how much these additional wait times for the customers on top of their threshold would cost the system. That's how I calculated these numbers. And I'll tell you in a second how. But whatever is in these variables is the additional waiting times on cost of customers on top of their threshold. That will cost me something in a week. And these are those numbers so that I can calculate how much is the additional cost of extra waiting on top of the threshold in a week. Let's go back to Arena, press OK, and press OK. And save. And the last thing I want you guys to do, so if I run the simulation right now, the simulation is not going to show these expressions, the value of these expressions to me, right? If I want the simulation to report something that I calculate in the model, I have to define statistics. Remember, we talked about that in a couple of minutes ago. So then I'm going to define a new statistics, and this statistics is basically the total cost. And peak output, I'll explain in a second one. Oops. So for the type, as opposed to time persistent or tally or counter or anything, pick output. So what does output mean? That means calculate these statistics at the very end of the simulation and just put it in the output on the report. Okay, so that's what output means. Calculate it at the very, very end of the statistics of the simulation. And what is this statistic? So here on the very top, you see you have expressions. If you click on that value, so what I want to calculate. In the expressions, remember we calculated the new resource cost. I want that plus another expression that we just calculated was excess wait time cost. I want that as the total cost plus that cost that we calculated here, 12,820. That's the fixed cost of everything we already have. And then this is the cost of additional resources. And this is the cost of the extra waiting time in the system. And this is the 12,820 is the cost of just whatever I have, those 11 technical staff and sales people and so forth. Press OK. And so this is output, right? So that means when we run the simulation, we just see the results, and this is calculated at the end of the simulation. Okay. There's not much left, so let's see what errors we get. Hopefully not. Okay, thank God it's running without error. Then I run and I finish. Here, if I go to the user define, you see I have counter, I have time persistent, now I have output too. And then I click on the output. Here, total cost is $21,020 in this scenario. Okay, so that's what I calculate as total cost. Could you guys run? Everything is fine? One thing I want to tell you guys, here in the cost, I didn't calculate the cost of the calls that were rejected, right? So our total cost was just the cost of new resources, excess waiting time, and the addition, and the original, just the cost of staffing. So this is the cost per week. If I wanna calculate the cost, well, one thing that I wanna calculate is the percentage of the calls that were rejected. And if I wanna calculate percentage of the calls that were rejected, let's go to the stat. Percent of calls rejected. And let's define this as output as well, because when I run the simulation, I want to see the result. So on the build expression, I'm going to the calls that were rejected. So I have to calculate total calls that were rejected divided by the total attempted calls, right? That's where I get the calls that were rejected. So for the calls that were rejected, I have statistics, the counters, right? The value. So NC period 1 gives me the current value of a counter period counter for period 1, which counts number of calls that were rejected in period 1, and put the parentheses at the very start because I want to add all of these. Period 1, period 2. So do it all the way to period 10. So basically I added all the number of, the value of the counter, the current value of the counter for all these counters. At the very end, when I calculate total calls rejected, I want to divide it by number of attempted calls. And that's the record I have. If you go to the record value, you have NC attempted calls. So that returns the number of attempted calls that you calculated in the record. So the total calls that rejected divided by number of attempted calls. And we can, at the very start, before the big parentheses, multiply it by 100. So at the end, it returns, not in terms of the, so at the end, for example, it's 10%, it returns 10 as opposed to 0.1. So that's what this 100 does. So basically what I have here, just so you guys see the formula, is this. In a big parenthesis, I calculated the sum of the value in all these 10 counters, which gives me the number of calls that were rejected, and then divided it by number of attempted calls. That gives me the percentage of calls that were rejected, and I multiply by 100 because I don't want to report 0.2. I want to report, for example, 20% were rejected. So that's why this whole formula is. Okay, so there is this big parenthesis at the start and at the end. Make sure to save and let's run it one more time. Output. So when I go to output, I see two. One is percentage called rejected. So about 10% of the calls were rejected, and the total cost, I see that as what time is it? 12:58. Let's see first. What is this? Okay. First of all, is there any question so far?
Professor, I have a question. I think you didn't initialize the variables.
Yeah. So that's one. And no. For the variables, I'm fine. So you can initialize. So for now, the initial value of all the variables are 0. So that's fine. If you want to find out, oh, what if we add this number of customers or that number of customers, just go to the variable here and just change this, new sales, new tech people, and so forth. Okay, so I don't have time. I'm not going to play with this, but the way we created the model is that you can just easily go to the variables and say, okay, what if I add, for example, 2 more hires? So that's the initial value. So the initial value you specify here, you say add, okay, what if I add actually 3 more sales staff? Okay, press okay, and then, okay, that would be your initial value for these people. And then if you want to add, for example, and if you want to change from 3 to 5 people and so forth, you can just change it here. I'm not doing it right now because of the time, but you can play with these cells, technical 1, technical 2, technical 3, number of staffs, and technical all, change the initial value, change the initial values. That means you are adding more staff. Run the simulation one more time. Look at the number of rejected calls in period 1 to 10 and see if adding more staff has decreased the number of rejected calls in those periods and so forth. And look at the cost and how the cost has changed. Look at the percentage of rejected calls, how those have changed and so forth, okay? But one thing I do want to mention before you guys go is that, remember here I calculated this, we use this entity.waitTime. So this is a built-in attribute, right? For this attribute to work, always we have to go to run setup, and in the project parameters, this costing should be checked. So that's something that we have to check for that built-in attribute to work correctly. Okay, so every time we use entity.waitTime attribute for any reason in the model, make sure you to come to project run setup, project parameters, and check the costing, because that function will be activated when this is checked. And this is pretty much all I want to say, but there is only one thing, guys, since you have it in your homework. So when we go to the run setup, here is where you can change the number of replications. And in the homework for, I think, question 2 and 3, I have asked you guys to run a simulation for this specific number of replications and so forth. So for now, I want you guys to keep the statistics check, keep the system check, and just change the number of replications. For example, here I'm going to run this for 5 replications. And so I'll explain later, since I don't have time right now, but when we come back next session, I will explain to you what these checks mean and what if we don't and so forth. But for the homework, keep both of them as checked and then change the number of replications. Let me see who said what. And then when I run the simulation, you see here, I see this is replication 3, replication 4, replication 5. Okay, so yes. Who said? Okay. Jingzhu has asked, does the entity wait time means the total wait time in the system of any entity? Yes, the waiting time in the queue or anything we have defined as wait for each entity. Okay, so I ran the replications, and here you see in the overview, I see the results, and I look at, for example, entity. You see here, I see number of value added time, and then here I see half width. That's something we didn't have before, or it just didn't have the right value. So here, the simulation calculates a 95% confidence interval for all of these results. So we run 5 replications, as if we run the same simulation 5 times with different random numbers. The simulation gets the results for each one of the replications, and then at the end, it reports the average of all those 5 replications, and then a confidence interval for those replications. So when I ask you that, for example, what is the waiting time in the system for technical call type 3, calculate the average and a 95% confidence interval, you have to report the average and then add this to this, that's the upper bound of the confidence interval, and deduct this half width from this number, that's the lower bound of the confidence interval, okay? So that's what it is. And then if you want to see the results of each replication, just click here on the replications. Then if you open this plus, you see replication 1, 2, 3, 4, 5. You can go here and see the results of each one of the replications. Okay, so that's why you see half width. If I just look at one replication, I don't have anything for half width. It doesn't have a meaning because it's just one number for each of one of these things that I'm looking for. So you see the results of the replications here. And at the end, in the overview, you see the summary of all the replications. That's why here, when we click on the entity, we see the values, average of all those 5 replications and the confidence intervals as well. So these are the upper bound of the confidence interval and the lower bound of the confidence. So 11.69 plus 2.55 gives me the upper bound of the confidence interval. 11.68 minus 2.55 gives me the lower bound of the confidence interval. So that means the total wait time for the product 3 is between 11, is on average 11 minutes, but it varies between almost 9 minutes when we deduct this value from here, and between 9 minutes and 13 minutes almost when we deduct this value from the average and add the value to the average. So that gives me the confidence interval. So if I ask to report the average and confidence interval, just make sure you know what to report. So that's what I wanted to cover for today. Sorry guys, it took longer than class time, but it's just this class is just too much material. Any question I can answer? Any question? Good. So guys, then you can finish the homework. And remember I said your exam is next week, and exam covers everything by the end of chapter 5. So everything we did today by the end of chapter 5. So we just finished chapter 5 completely. So everything we have done up to end of chapter 5, up to the end of today is in the exam. And exam is next week. Is similar to the homework assignments. I give you 1 or 2 problem statement, you develop the model, you answer the questions, similar to homework. You create a Word file, you put them in one zip file, you upload it, and that's it. Any question, guys? If there's no question, I see you next week. And feel free to email me if there's a question, and come to my office on Wednesday.